Hello and welcome to a new episode of the Primary Maths Podcast, the show where we talk all things primary maths. I'm John Cripwell, and my guest today is one of the UK's most influential maths communicators. He's a prolific author, speaker and educator, best known for making maths engaging and accessible. His books, including Why Do Buses Come in Threes, Maths for Mums and Dads, and Much Ado About Number, have helped hundreds of thousands of readers see the maths in everyday life. So you can see why I was excited to have him join us today. He's also the brains behind Maths Inspiration, a nationwide programme of interactive theatre shows for teenagers and children, and he regularly pops up on the BBC Radio 4's More or Less programme, amongst others, demystifying the maths behind the headlines. My guest today is Rob Eastaway, and I'm delighted to have him on the show. Welcome, Rob.
John, thank you. I'm delighted to be on, and golly, I hope I can live up to that. It's always odd to hear something described and stuff you do. But anyway,
to be honest, Rob, I could have gone on, couldn't I? You've got a whole career of accolades and things all around maths, which is just a testament to quite a number of years spent thinking and talking about maths, which is fantastic. Yeah. How did you find maths at school? Was it a subject that you enjoyed?
Yeah, I was particularly good at arithmetic from before I went to school. Apparently, I remember my dad saying you could actually add things up, that were quite difficult. Then you went to school and they taught you how to do it, and it slowed you. So it took me a while to figure my head out. I mean, I remember none of that, but I was always into arithmetic. I was always quite strong at maths. I probably wasn't the best in the class, but I was up in the strongest in the class. But I loved puzzles, actually, especially, and that's what sort of kept maths engaging for me throughout, from primary through to secondary, discovering that Scientific American had a column about recreational maths by a guy called Martin Gardner, reading his books, discovering puzzle columns. So those, it was always the fun side of maths that I was lucky enough to know about, and that really thrilled me. Magic tricks as well. And then we had a good syllabus. I did a thing called SMP maths, and it was really interesting. I had good teachers. So I kind of coasted through maths all the way through school without ever thinking I was a mathematician, I liked maths. Yeah.
It's interesting, actually, what you just said about being good at certain areas of maths before you started school and then having to unpick that slightly. I think sometimes the curriculum can, and certainly our current primary curriculum, focuses a lot of time and energy on formal written methods being the end point, which, if you're not careful, I think can take some of that enjoyment and curiosity out of maths.
It is interesting. I'm sure we'll come on to it, but how much emphasis is put on written methods when you think that actually by the time you leave school, very few people, it'd be interesting to do a survey of adults. How many times in the last year did you use a written method?
Yeah.
It's much more likely that they will use mental methods and calculator spreadsheets.
Yes.
And big calculations will be entirely with electronics, because the old, what if you haven't got a calculator, so rarely applies now that it's almost, it's a silly claim to make. But when you look at numbers and think that doesn't make sense, you're using a mental arithmetic method. You're not writing it down. So it's interesting, isn't it, that whole emphasis is still there.
Yeah,
it leads down a bit of a dead end.
As you say, sort of in everyday life, if I'm wanting to work out if I've got enough money to buy the shopping in my basket or whatever, I'm probably not adding things all up. Exactly. I'm more likely to be using estimating and having a good guess at what is in there, and that all relies very much on an understanding of number and how things go together and quicker ways of doing things. And one of my colleagues has always said that the best mathematicians do the easiest maths, and I don't think formal written methods are always the easiest.
Very true. Yeah. A lot of estimation methods are really simple. It's the skill, I realize, is in knowing how to turn difficult things into easy things. But
Yes. Yeah.
but then
And that
once you've
requires
turned it
quite
into the easy thing,
a
maths
deep
is easy.
understanding and a lot of time
Yeah.
spent on that, or intuitive understanding, perhaps. Anyway, I've already gone off on this tangent, which I am, liable to do, I'm afraid. I'll try and pull myself back round. But you didn't then go on to study mathematics as such, did you, after
I
school?
di- I didn't, because I thought sort of I didn't want to. I knew I didn't want to narrow down just to maths, but I was. It was sort of confirmed when I looked. We went on a school trip in year 12, and I happened to look at university, the first year maths exam, and I thought, I don't even understand what they're asking. You know, they're talking about algebra, and there's not anything that looks like algebra here.
Yeah.
This is not for me. This is far too abstract. Um, I was going to do economics, actually, and then I changed to engineering, and I'm glad I did, uh, because it was applied math. The course, the degree I did was mainly applied maths. It didn't require you to be an engineer, which was hugely fortunate from my point of view, because I would have been a really hopeless engineer. But and I sort of hung out with mathematicians. I always thought like a mathematician, but I just didn't have. We all reach our threshold, and mine was first year engineering maths,
Yeah.
grads, divs and curls. That's when I thought, you know what, I'm really, really struggling to get any further here. But
Yeah.
fortunately, it was enough. So,
It's interesting. I've come to the conclusion, having spoken to lots of people over the last few months about their experiences of maths and learning maths, that there is a point for everybody, I think, where maths suddenly becomes abstract, and it can be quite difficult to grasp onto what it means. Of some people, I think that happens quite early on. I was probably one of those people. And then for other people, it's degree level that it happens. But it seems to happen to most people at some point. Um, so then tell me about how, from engineering, then you've ended up talking about maths to hundreds of thousands of people through your books and radio and all sorts of things.
I need to sort of pick out the salient points, really. Otherwise, I could be, this could be the next 2 hours.
Yeah.
But where are the big breaks? The first really big break was when I was 16-ish, discovering that the Sunday Times had a mathematical puzzle column. Didn't have much social life. I was very small, very young, 16-year-old. So I thought I'll spend my Sundays doing this. And then I one day had an idea for a puzzle, and I set it out, sent it in, and to his, how wonderful that the guy who was editing the column probably realized this is some young lad who's done it. I'm going to
Yeah.
give him the benefit of the doubt, and accept the puzzle. So there I was, published in the Sunday Times, like at 17. That was a big deal, certainly a massive deal for me. It gave me huge confidence. Probably the thing that sort of got me into my, competitive university degree, and then and also utterly immersed me in recreational maths. That whole world. I continued setting puzzles for several years for New Scientist magazine and so on, and and then my first job was mathematical modelling, and I think the next massive break on the math side was when a friend of mine who'd worked with me in this consultancy, a guy called Jeremy Wyndham, as a reunion party in 1997, something like that, said, "Oh, you and I, we used to talk about math stuff at lunch. How about we do a book about fun maths?" And all the energy was from him, but I'd already done a, a another puzzle book type thing, so I had some publishing experience already. But I said, okay, let's do it. And that book became Why Do Buses Come in Threes? And it absolutely I remember that the publisher had a typesetter who saw it, and I overheard him saying to someone he was with, "Who's going to buy a book on maths?" And we were thinking, is this going to get remaindered? Well, the Daily Mail gave it a page. I think that was the secret. It went absolutely crazy. I was on every local radio, like 5 Live, everyone else, Radio 4.
Yeah.
And it became a bestseller. And I started getting asked to go in to do schools talks. And it was completely new to me. It was still just the era of acetates, overhead projectors. We're talking around 1999, 2000. But no one else was doing it. And so I suddenly was doing maths talks to hundreds of kids, and in the land of the blind, the one-eyed man is king. No one had ever seen anything like this before. Someone talking about maths of everyday life. So I look back and think at some of the awful materials. I did, but it was fine. It was better than what they'd been seeing. And that evolved eventually to start doing big talks and then setting up Maths Inspiration, having seen that there were events in London for affluent schools to go to lecture days. A guy called Simon Singh, who you might have heard of, wrote some great maths books. He and I decided to put something on in Manchester, which was away from where all the stuff was happening. We did it in a university lecture hall, which was too hot. So the year after, I said, we'll do it in a theatre, which is much more atmospheric. And that set off Maths Inspiration, which is the sort of the project that holds everything else I do together. And these are interactive lecture shows for year 11, year 12, with the mantra, there's more to maths than taking exams. So that has grown and grown. We've now got 40, 50 people have been speakers over the years, quite a few of them regulars. And it's great because we're in theatres, sometimes in front of, we'll be doing a show next week in front of 1,000 teenagers at the Cambridge Theatre, which is where Matilda is. We've got the Matilda set behind us. We're in the daytime. And it's just so cool to be treading West End boards with a bunch of mathematicians who are good team players. They're not lovers, so that's how it's expanded to this massive thing.
That sounds wonderful. And with the aim of those shows, as you say, to show that there's more to maths than just the exams, but you're aiming to inspire that. It's called Maths Inspiration. What's the aim to? What are you hoping they will take from it?
Well, the great thing is you've got the full gamut of people there, from kids who already love maths, but they're being affirmed that their love of maths, they're not abnormal, and others who are just seeing their peers enjoying it. And I think it was always to encourage people to pursue mathematical subjects to another stage beyond where they are now, but also just to expose them to a side of maths that they may not see, especially at GCSE, which can be incredibly dry. 2 years of practicing exam questions, which are very little to do with what mathematical beauty is like, really. So among them will be the future maths graduates, future teachers, just people who go away with a better impression of maths. And hopefully when they're doing their exams, they sort of think, there's some I now kind of know why I'm doing this, because I might want to go into this job in, artificial intelligence or in stats or whatever it is. So, it's a field trip. Every other subject gets a field trip. Why shouldn't maths?
Absolutely. Yeah, absolutely. And it can be one of those, not to over egg it, but it can be for, if you're talking to 1,000 people, even if you just change the viewpoint of a handful of those, it has a huge impact.
For some people, it is that moment, and you never know what that moment's going to be. There was a show we did in Leeds. A teacher told us later, one of her students had been planning to be a ballerina, and she ended up doing civil engineering. That is quite a transformation.
That is. I hope she kept up the ballet in her spare time. But I mean, for me, I was saying to you before we started recording, maths was not a passion of mine at all at school. If you'd have told me at 16 I was going to spend my life talking about maths, I'd have laughed at you and probably ran away. But I was lucky enough when I did my PGCE to have a fantastic lecturer who was so passionate about maths and really made it engaging. And suddenly helped me to see connections that I wasn't aware existed, and see maths in areas that I didn't think of as maths at all. So how you've written about maths, as you say, you started off looking at maths in everyday life, a lot of statistics and probability and that sort of thing in that early book. Why do buses always come in threes? Where do you find the inspiration for these things? How do you see maths in the everyday world?
I mean, if you're around long enough, things come to you. I do have a nose for things, it's the things that I find interesting. So it's like going on a beach looking for, suddenly you see something a bit shiny. I like that. So I just filter those out and reading other books, reading books by Ian Stewart or David Wells or whatever. I remember it was David Wells's beautiful book about mathematics or whatever, had a geometry chapter talking about triangles, but it included, did you know that the best place to place the ball for the widest angle for converting a try in rugby is it the tangent to the circle that passes through the, anyway, it was this diagram. I thought, I love sport, and there's a bit of GCSE maths in where you place the ball. It's cool. So that straight into my repertoire. And that was just, over the years, I've just collected these things. I've been lucky enough to meet some amazing people. David Singmaster, sadly no longer with us, who did the Rubik's Cube stuff. He lived close to me and had a puzzle collection like a grotto. And so I just pick out the best bit. And sometimes, the best bit would be in a book that's otherwise of no interest to me whatsoever. There's one bit there. So I've definitely just picked out the bits that I like. And I like it being connected to something amusing, everyday life-ish, because I want to talk about it to people, and that's what they're going to be more interested in as well.
Yeah, so finding those things that people can relate to. I think we've used the word relate, or I have anyway, used the word relate or relatable several times already in this conversation, and I think that's often the bit that's missing about maths. You say maths to the population, and a large proportion of them think of algebra, formal written methods, and trying to find an answer and being right or wrong, at school usually, I think. So I think any opportunity that we can take to widen people's perception of what maths is really important. Speaking of which, you've sort of had a fascination with the history of maths, which is also something that we go into quite a bit on this podcast. But you've totally outdone us on that, because your last book was Elizabethan, Shakespearean. How did you end up looking at maths and Shakespeare? What most people would think of as two completely different ideas.
So you could imagine it could have been, let me crowbar these two things together just because no one's done it. Fortunately, it wasn't that at all. It was because there was a maths teacher conference in Stratford-on-Avon in 2022. And I thought, Shakespeare, it would be a nice joke to do a workshop pseudo around Shakespeare and math. So we're talking to be or not to be, the algebra of Hamlet, cheesy jokes that math teachers like, and I did it with my friend Andrew Jeffrey. We did a joint thing. It was very tenuous, but as part of it, I had just checked, does Shakespeare ever use the word maths? And he does, and he uses it in an interesting context. And I pulled on that thread, and for the next year, I just absolutely went, that thread turned out into discovering so many things that I'd never thought of before, but also Shakespeare experts had never thought of before. Because why would they? Because why would ever anyone look at Shakespeare from a point of view of maths? But it turns out, the most fascinating starting point, the thing that really made me realize this is going to be interesting, is that in the 16th century, when Shakespeare was alive, his dad was the last generation in England who only learned Roman numerals. And Shakespeare was the first generation to use what we take for granted, the Indo-Arabic numerals. And this was a cool new idea in in Elizabethan England. And Shakespeare was excited by it. And there's little clues in what he writes. This cipher, the zero, that can make things bigger, and yet it represents nothing, is just his cup of tea. And and then you discover all the other mathematical things that just happen to be happening in his time. So even if he wasn't studying maths himself, he refers to the Mercator maps that were being done. He doesn't talk about Mercator, but he talks about all the lines on the grid and compares someone's face to being like all the lines on this map. So he's hearing about these things and talking about them. And from point of history of maths and so on, the history of the Roman numeral, primary kids have to learn Roman numerals now.
Mm-hmm.
They must at times, and their teachers thinking, why?
It is possibly one of the most common questions about the curriculum, Rob, to be honest, is where did this come from? And is it just because Michael Gove, when he was looking at the curriculum, thought, well, I did it at school? Is that why we're doing it? So yeah, you're right. What is the point? What's the point?
And yeah, but if you were to suddenly do a module, so I've got a talk now I do for year sixes, but I'd also do it for year 7, 8, 9 and adults about the history of Roman numerals. And firstly, what they look like the Romans, they know how to do Roman numerals, right? So 40, that's XL, right? No. Colosseum, XXXX. They kind of made it up as they went along, 4 X's. The Doomsday Book, here we have French, English writing all the records of, Britain. How are they writing 9? Not IX. It's VIII. But then 40 is XL. So it's kind of so they only invented the rules for this really in sort of medieval times. We now say you're supposed to do this. Well, only medieval supposed to do this. I mean, if you look at a clock, I think we've had this conversation separately.
Yeah.
The 4 on a clock is almost always II because it looks good.
Yeah.
So the history of numerals and how they're used and even today they're used for different status. Sometimes they're to make something look really important. So you'll have an IV, Charles III. He's a Roman numeral. But movies that take themselves seriously, Rocky IV will be IV. But ones that don't take themselves seriously, Toy Story 3, that's just an ordinary 3. And then the hierarchy of exam questions, you've got question 1, part A, little Roman numerals. So those are the low status ones. And then there's the cryptic ones at the end of the film where they don't actually want you to know when it was made. So they'll put it in Roman numerals. So by the time you try to decipher it, it's off the screen. So you don't realize it's a repeat. I mean, that's why they did it, I think. So they're all over. But the fascinating thing in the 16th century is watching in slow motion how people made the transition from using counting boards and writing the answer with Roman numerals to using new arithmetic. And I found manuscripts in Shakespeare's time of people trying to practice long multiplication and getting it wrong. It's really funny. But good on them for trying. So
yeah, well, I mean, and we're talking, 400 years ago, aren't we? 500 years ago, and then just last week I was teaching to some teaching students how to do long multiplication because that wasn't something that they had learnt at school when they were at school in the 90s, early 2000s. It had kind of gone off the curriculum, and we were using different methods like the grid method and things. And now we're back to these methods in the curriculum, for better or worse. My personal opinion is that there's definitely a place for them because it really does help you understand how numbers work sometimes. I think,
and they're the most efficient.
And they are the most efficient.
Shakespeare would have learned long multiplication looks very like the Michael Govian approved vertical column thing. And one big difference is if you look back, there was no multiplication symbol. They hadn't invented it yet. So you're just supposed to know. And they didn't do the little carried numbers. They just kept it in their head. So lots of little things. You say, "Oh, that's wrong." No holding place value 0 on the second line. But interesting thing about that, I believe that the 0 on the second line, which we all say is good practice to put it there, placeholder, only became popular in, I think, the 1980s. So I think if you were to find someone's grandparent, how they do it, they don't stick the 0 there. And they have that in common with Elizabethan England because they didn't either.
Well, it's interesting. I mean, the way that a lot of people would say at the moment that you might teach that is not to just randomly put the placeholder there, but actually think about the fact that when you're multiplying by a 10, what that actual number that the product is that you're creating. It's not a single unit of 1. It is a multiple of 10, and therefore that's why you would put it in there. Just to try and help that conceptual understanding rather than just a procedural, by rote. But you're right. When I was taught how to do it, there was nothing about why you were doing that. It was just put the 0 in there and then everything will work. And I know that you like the magic of maths, and so do I. And doing maths tricks and things with maths is, doing magic tricks and things with maths, I think is wonderful. And but I think unpicking why they work is also wonderful.
Exactly. In fact, it's interesting when I do, because I've seen maths magic talks over the years, and once or twice, especially a long time ago, someone come in and do a trick. It had numbers, it used maths, and they'd say, "Wow, isn't that amazing?" The kids would go, "Yeah, that's amazing," but I've got no idea how it worked. It was like that's just reinforced what maths is, which is it's like a magic trick. So
Yeah,
it's an absolute rule of mine that when I show tricks, the whole idea is to wow and then explain how it works. And then they're so excited, you want them to be excited enough. They take it home to try it out on a parent. And
yeah.
then you've given them a bit of viral maths that spreads. What did you do at school today? I've got a trick. Fantastic. Very rarely happens that with my kids never came home and showed me anything that they'd done at school.
No, no.
But yeah, so
No, I pick up my children from school, and they still have that time honoured tradition of answering, "What did you do at school today?" with, "I have no idea. I can't remember." Yeah, so to come home and have a little bit of power that they can show something off and amaze people with, I think is a wonderful thing. So that's something that you do, isn't it?
yeah, and
Rob?
that's kind of how I first really got into going into schools, before Maths Inspiration took off, and actually a bit before Why Do Buses Come in Threes came out. My nephew, who was in America, asked me to go into his school. I thought, oh, okay, I'll go in, show off my English accent, which of course worked a treat. But I thought a couple of tricks I remember from school. There's one with cards. Is your number on this card? Yes or no? Yes or no? Yes or no? And then revealing, is your number 7? All of them completely gobsmacked. That's still a routine part of my routine. Kids absolutely love that. They're so excited by it up to year 7, I'd say. And yeah, I started thinking I really enjoy doing this. So I've and for a long time I'd do more talks in primary key stage 2 than in secondary. Um, Definitely around the time when Maths for Mums and Dads came out, I was in primary school every week doing things. And I've always, my favorite stuff was the tricks, the puzzles, the curiosities, but explaining why. But the hook is the wow of a trick.
Yeah, yeah, absolutely. I mean, I often used to use that as a teacher. I would start off, particularly at the start of the year, as I was getting to know a new class and things like that. We would do some maths magic together because it was a great way of practicing some number work for one. If you have I can guess what numbers in your head sort of trick.
Exactly. I think of a number trick. I mean, I've
Yeah,
got a whole, it can be, if I want it to be, and I generally got other things to show them, it could be 20, 25 minutes of mathematical gold just doing a think of a number. I'll do it to you now, even though, of course, you'll know this and anyone listening will know it. But in the 9-year-old child's head, this is amazing. Just think of any number you like. Maybe you want to make it small if you're in year 4,
mhm.
but up to you. And I'd like you to double that number. And then when you've doubled it, I want you to add 10 to your answer.
Okay, yeah, I'm
Okay.
still with you.
Okay, good. And now, hardest bit coming up with that number you got now, I want you to divide it by 2, half of that number.
Okay,
Okay. And now I want you to take away from that the number you first thought of.
got it. Yeah,
Okay. And I'm just going to see if I can, if the energy is coming, I'll just hold my hand out to see if I can. Oh, my word. Is it 5?
it is. Yep, incredible.
I mean, so much. So here's various observations of doing this. Firstly, in fact, I've slightly relented a bit recently, but traditionally for year 3 upwards, I've always got them to do it in their heads entirely. No writing down. They've got no pen and paper.
Yeah.
If they're at year 3, they're in pairs. My observation would be, if they're year 6s, about 80% of them finish on 5. Depends on the school, but it's a high number. Down to maybe 40% in year 3, 50%. But enough for a wow around the class, which says that their mental arithmetic is pretty good, even though it's not encouraged. That's one thing that I observe. Second thing, of course, not everyone's ends on 5. And the way that I then take it is to say, oh, who can give me a number that doesn't end? And then we do it jointly. And then the penny drops, and that's that. And of course, they set the challenge. You get a smart aleck who will say 2.5 or -3. and it's
Yeah.
me. Oh, well, you want -3, then let's do it. Or they'll give a big number. Of course, these days they all say 6, 7, ha ha, which is
Yeah.
better than other numbers. But
Yes.
actually, with
Yeah.
67, okay, who can double 67? They said, right, okay, it's a challenge, right? Ooh,
Yeah. Yeah.
34, 144 divided by 272. Okay. Um, and then I tend to finish that. Well, two things. Firstly, I then say, okay, who can give me the biggest number? What's the biggest number anyone can give me? And they love that. So, they'll start at illions. They'll say Googleplex quite often, but a quadrillion is good. And I write that up and I say, well, it's too big for your calculator. So I hope you know your quadrillion times table. Think of a number, quadrillion. It's hilarious because it's so big. Double it, 2 quadrillions. So they do know their quadrillion times table. Add 10, 2 quadrillion and 10. Half of that, 1 quadrillion and 5. Take away the number you first thought of. So it actually makes it easier. But
Yeah.
they've just done a calculation that their calculator can't do. And they
Yeah.
end up on 5. And that is cool.
And that's wonderful because it really does expose the number system and how it works, doesn't it? The 2 lots of whatever is just 2 lots of whatever. And in fact, as you say, the bigger the number in some instances, as long as it's
The
a
easier because
round
it
number, it's
segregates, it
easier.
partitions them out, which is good. Yeah, I rarely do this unless there are parents present as well. But I say, well, why does it work? And I just show a little, think of a number. It's marbles in a bag. And by the way, I see what your response. I show a bag and I say, we should give this bag of marbles a name. We don't know how many marbles there are. Anyone like to give me a name for this bag of marbles? Would you like to guess what 70% of children call bags of marbles? What's your hunch telling you?
A marble bag, Rob,
No, they give
obviously.
it a name like,
Oh, do they?
yeah.
Bob?
You're right. It is
Yeah.
Bob. And I've
Yeah,
actually
yeah.
got Bob on my next slide when I do it with slides. And they come, how did you know? It was like mind reading.
Yeah,
Well,
yeah,
anyway,
yeah.
Bob.
No, I've worked with kids long enough. Bob is a safe bet usually. Yeah. Um, but we would. So I would do exactly that little bit of maths magic, and then unpicking it would be my entry when I was working with Year 6 into sort of early algebra and just the number that you start with, we'll call that A, and then you can actually see how it progresses through, and why we end up with 5 at the end of it. It's a really nice way of just explaining something, where the variable could be anything, um, and it's a way of, as you say, making something fairly abstract make sense.
Yeah. And it's
So
funny
yeah.
actually, because my general routine of, it's about a 50-minute thing, 55-minute max for year 5, 6. And if I sort of sum up, I say to someone later, well, I was with some year 6s today. We covered algebra, arithmetic, prime numbers, factorization, topology, was a binary numbers, and there's a couple more things. And they say, oh, wow, were you with them all week? No, that was in 50 minutes. And although we mentioned those things, I don't think they ever really felt they were doing maths because it was in that. So you can sneak in some really sophisticated ideas in an incredibly painless way.
Yeah.
So in a very short space of time, I mean, it's, kids can be, you set them things. It's amazing how far they can get when they're not supposed to have studied this yet. So, yeah.
Rob, you mentioned maths for mums and dads. It's been around for a long while. I remember somebody giving me a copy of it actually when I was a teacher, put it on my desk and saying, as maths lead, have a look at this. It might be something that we want to, and we did. We suggested it to parents and things at the time as a resource. We know that lots of parents feel anxious about their own maths confidence and their own maths ability. How have you tried over the years to sort of not tackle that? It's not your job to tackle that, but to engage with that and encourage parents to be engaged with maths
Well,
themselves.
it really helped to be a parent to see what it was like on the parents. A parent who's good at maths. When I suddenly was bamboozled by techniques that I was seeing and terminology that I didn't know what it meant. What's a number line? What's partitioning? I know what they are in different contexts, but not this. So that was new to me. Just the language and some of the techniques and stuff. so, I've a lot of sympathy with parents who are quite intimidated by what might be routine speak amongst teachers and in class, but comes across as jargon when you're a parent. And then the last thing you want is a subject you're grappling with when suddenly there's a, a name for something you didn't even know. And I always say to them is, there are two rules. Firstly, the teacher is always right. And secondly, rule one always applies. So, they'll show their kids how about doing it this way. And the child doesn't want to be taught a different way. So the parent's role, as much as anything, is to complement what's going on in school by making maths a pleasant, matter-of-fact part of everyday life, by playing games with your child, not leaving your child with
Yeah.
electronics.
Yeah.
Play a board game, play,
Yeah.
snakes and ladders. And if you've got no time, play treble snakes and ladders, practice your 3 times table, and the game's over 3 times as quickly. So, and I used to play games, of course. I mean, I'm comfortable with this, but, I played games with my kids all the time. In the
Yeah.
car, you think,
Yeah.
how are we going to pass the journey? Right. 1 point for a sheep, 2 points for a cow, 5 points for a horse. Everyone's suddenly
Yeah.
adding up and excitedly
Yeah.
keeping score. So there's a book I did that had very little engagement, and I was disappointed because it kind of summed up the way I would want a parent, which is called Maths on the Go. I don't know if you ever saw it. It was in the series, Maths for Mums and Dads series.
No.
It implied from the cover that it was for kids, where it was actually for the parents, how to play maths with your children. But it was all my tips for how to make maths fun for you and your child, basically.
You're absolutely right. There's some fascinating research on the impact that just those maths conversations that you might not even think of as maths conversations have, even on preschool age children. Just simple things like counting out the numbers of knives and forks for dinner, and we've got the right number of plates, and we share these out between everybody equally, and that sort of thing has a huge impact on very young children. And the other thing that you mentioned, which is board games, also some brilliant research has come out to show that the impact of just using linear board games and counting, moving counters along, rolling a dice, counting them out, huge impact on cognitive development around number and things. So, totally agree with you on those points.
And actually, one bit of advice that I like to give parents, this may resonate with a lot of teachers, is I first do a survey. How many of you have got an analog clock somewhere in your house, in a place where you're all together, like in your kitchen? Like less than half of them, because there's a clock on the cooker and everyone's got a phone. But a communal analog clock, it's just priceless for share, and visually see why it's 8:25. It's only 5 minutes till we go. You get this visual sense of what the time is. Wow, that hand is getting close to, we've got to be out the house. And you could just very gently just get used to telling the time together. And so many children struggle with analog clocks. And it's partly because they don't see them. They don't live them.
No, that's right. Since the curriculum was written back in 2013, 2012, introduced in 2014, teaching analog clocks is still very much part of the year 1, year 2 curriculum. And yet the children that are coming into those year groups now, a lot of them have got very limited or little experience of analog clocks at all. Because as you say, my watch is digital, the time's on my phone, it's on the cooker, it's on the TV, and the car, and it very rarely is it analog format. We've just been doing some work here actually on remapping how to teach time, and we're now starting. We always started with analog, but now we're starting with the digital because that's what they're familiar with, and then beginning to link it to, well, what does that look like when we move into an analog format?
And by the way, talking of history and a suggestion, a thought, you go back 500 years and what were clocks like? And there's one at Hampton Court. It's the only one really that was available in this country. It's a 24-hour clock. But the thing you notice is it's only got an hour hand. There was no minute hand because they didn't do minutes. There was too much detail. They didn't need that. How much easier it is to tell the time when there's only an hour hand? Let's go back 500 years and then you say, well, what hour is it pointing to? Well, it's sort of pointed to 2. Good. It's about 2 o'clock,
Yeah.
but it's just after 2. In fact, it's about halfway, so it must be 2:30. That's how people told the time. And the minute hand confuses things, so just learn it with an hour hand. And
Yeah, that's a really good. I've never thought about that, but if you started with the hour hand and how that moves, but interpreting how it moves between the hours as well, that's
because it does tell you you don't actually need a minute hand.
no,
It's just the minute hand that helps you to be much more
more
accurate.
precise. Yeah, yeah, yeah. That's interesting. I've never thought about that before. Um, I was also just thinking it's slightly ironic, actually, thinking about the parent conversation again, that for a lot of my early career, I was told by parents, I learned these column methods, and now you're teaching them a different way, and I don't understand those. And now I'm having the same conversations with parents about, well, you're teaching them these column methods, and I learned it a different way. Thinking, yeah, that was our fault. Yeah,
You're
stick
dealing
some-
with this time lag, aren't you? Teachers are like, parents are like
Yeah,
30 years
yeah.
behind whatever the current thing is, so you have to map back.
Well, it's ironic, isn't it? As you say, maths in its current form has been around for about 500 years in this country, and yet, we're still finding ways to make it slightly more complex than it probably needs to be. Yeah. Um, Puzzles, I know, are your passion. It's how you got into all of this, as you say. Do you think there's? I think I know the answer to this, but do you think that there is still a place for puzzles?
Yeah, well, funnily enough, so there's a nuanced answer to that, which is, I mean, of course, yes, they're fun, the reveal, the surprise. However, my order of fun maths to include, if I want to engage someone, I think my first thing would be games, followed by magic tricks, or so those two, followed by puzzles. Because the thing about puzzles is they're brilliant when you know the answer, or if you're the kind of person who likes sweating over the puzzle. But for a lot of people, it's a big barrier because they can't do it. It's
Yeah,
yet more proof that they can't do it. And a lot of puzzles also have a surprise answer. I happen to be the kind of person who likes surprises. I like getting it wrong, going, oh, how I fall for that. Some people really hate it because what they like about maths is the one thing when there's no surprises. And of course, I would argue that maths should be about surprises, but not everyone feels that way. So you've got to pitch the right puzzle in the right way, not the I'm clever, you're not type way.
yeah.
And there's one puzzle that I've used for years that is just a story of a family with a square swimming pool with oak trees on the 4 corners. And I just say, the family was stuck. They wanted the pool to be twice as big and still square, but they were told they can't cut the trees down. Can you help them, please? How can we make this twice as big and still square and not cut the trees down? Now, it is a puzzle, but the great thing is that kids have lots of ideas which aren't the answer in the back of the book, and that make and in fact they always come up with answers in this order. They did last week. Firstly, well, I don't know if you'd like to guess. Actually, what do you think? So, got this swimming pool with 4 oak trees, you can't cut down. What do children suggest as ways of making the pool twice as big without cutting down?
Do they think about building up?
They do sometimes. That's not one of the top 3. The
Okay.
double-decker one is with a slide down is cool, but that's a rarer one.
That's what my childlike brain went to immediately.
That's good.
And then,
That's
of course,
good.
I thought, well, maybe dig down, and then you've got.
That's the first one. Twice as deep. Yeah, it's twice as big. After all,
I'm not sure if that's what we mean by twice as big in terms of swimming pool usable area, but
well, exactly. But I pose it with natural language, saying twice as big. Therefore, twice as deep is, and I do that deliberately because I don't want it to sound like a maths question. I want it to sound like a problem. Yeah. So, of course, they suggest twice as deep, and I say, oh, yeah, that's true. I didn't tell you the dad can't swim very well, so it needs to be shallow enough, which has not stopped them in the past saying make it half as deep one end, twice, Yeah. But then I say, no, I meant the surface area, so which is fine. So they then suggest. So the second one, which you're probably thinking of, which is build the pool around the trees and make the trees islands, so you swim out to the trees.
Oh, nice. Okay.
They always suggest that. I think that's a lovely idea, but it's going to dig around the roots, so the council say that's not allowed. So we have to think of another one. The third one they think of is build the swimming pool somewhere else. Find it's the total lateral thinking. Gordian knot.
Yeah.
You think, this is the kind of thinking we want in this country.
Exactly. Yes.
So it's a great suggestion. If only their garden was big enough. So anyway, that's what they come up with, and then I show them what a mathematician showed them. You know, they couldn't think of the answer, but a mathematician showed the family how to do it, and it's like you put triangles on the top, you make it into a diamond shape, and once they see me sort of with a pen just mark out, you know, the new pool, and
Yeah.
it's a wow, it's like a magic trick. And is it a square still? Yeah, in a helicopter, that diamond is actually a square. Is it twice as big? Oh yeah, let's draw in the diagonals of the original pool and fold them out. You've doubled every triangle. So we've done a little geometric proof. But they like it so much that they go and show their parents afterwards.
Yeah.
So it's a puzzle that they didn't come up with, but they love the answer, but they've learned something, and there was a low threshold. You know, it was easy for
Yeah.
people to suggest answers too. So lots about that puzzle is the kind of puzzle that I think is good. But nobody likes a smart aleck. And so the person who's got a puzzle and some of the kids always getting it wrong, that's a bad vibe if you do
Yeah.
that too often.
Yeah. We do a lot of work around problem solving, and I think there's a strong link, obviously, between puzzles and problem solving. Probably mathematically, the issue with, well, not the issue, but the problem with problem solving is that it removes that kind of um, lateral thinking that real world we absolutely want to encourage. But in terms of passing a maths exam, you've got to find the answer that's in the examiner's head, rather than the one that you might come up with, that shows your brilliance at thinking, which is a shame, isn't it? But
Yeah,
um,
I do a teacher workshop or a sort of a plenary thing called the problem with problem solving, and it's exactly that. Um, and I give examples of exam questions which sort of tore the beautiful maths out of a thing just to make it
yeah,
markable. And
yeah,
you know, there's one of them, the Baywatch problem, where you're on the beach as a lifeguard right by the sea, and then someone off at an angle in the ocean says, "Help! Um, I need help." And you think, "Oh God, I've got to get to them as fast as possible." So, because I could just jump in and swim in a straight line. But if you picture it, think, well, you don't swim very fast. What about running along the beach till it's the minimum thing and then swimming that bit? That's surely going to be quicker. But actually, is there a place in between that's even quicker? You suddenly realize you're sort of informally mathematically problem solving,
yeah,
at which point, if you're thinking mathematically, you now draw a diagram, you work it out, use a bit of Pythagoras, and discover, yeah, there's going to be an optimal point that's some like refracting light. That is fantastic problem solving, and it's
yeah,
accessible, and everyone's doing it from the moment you've prosed the problem. The Scottish exam board 10 years ago set a problem about a crocodile catching a zebra on the other side of a river, which was entirely the same maths. But it started by saying a crocodile wants to get there as fast as possible. The formula for the time it takes is this. Find the minimum time. I think so. It's no modeling. It was all computation,
yeah,
and no clue as to where this formula. You know, the world has come up with a formula. Well, actually, real maths is you come up with the formula. That's
yeah,
the interesting part. A computer can work out the numbers. So it's, you know, one of many things that's the exam tail wagging the maths dog. That problem solving in real life, mathematical, it's collaborative, it's fuzzy with real world constraints,
yeah,
and it's you get stuck and you go and have a cup of tea and come back the next day. That's all part of the process. Not
yeah.
you've got 90 minutes to cram as many as possible. That's not problem solving. That's whatever it is. That's a sprint. So
Yeah.
you've got me started. I will stop on how many criticisms I have of the notion of problem solving and how poorly exams model it.
Yes, and yet to me, maths is problem solving. That's
Yeah.
a way of explaining the world and helping to see ways through it. That's what maths does. But I don't think I recognised that I was doing maths when I was doing those puzzles and things. And sadly, for somebody like me, I would happily sit and puzzle over a crossword or something that English came very naturally to me. So I'm happy with that. if I saw Sudoku, that was numbers. Even though, it's not particularly mathsy really, it just happens to have numbers, but I wasn't gonna engage with it because of my preconceptions around it. So, yeah, we put these barriers up, don't we, with the way that maths is sometimes, um, explained to us, perhaps. Um, I time is running away with us, Rob. I could talk to you all day about this stuff, and maybe another time, we will. But just a final thought, as somebody who has seen maths, uh, not maths change, but the way that we think about maths change a little bit perhaps, or, different fads coming and going, and the world changing as well. We know we talk about AI a lot at the moment. We did a podcast on it a few weeks ago, and about how teachers might be utilising it and things. And you've talked about analog clocks, Roman numerals, or the way that things change. How do you predict the future for me? What do you think maths will still be important in 10, 20 years' time, as important as it is now?
Uh, I do think it will be as important. I think that kind of thinking is so important. As much as anything for challenging, for being able to challenge what's fed to you, you know, um, and for keeping the brain supple and all those sorts of so many mathematical skills. I do wonder, however, how much longer the kind of system we have will continue to function before it breaks down. The notion of exams and grades. And so, at what point will people realize those skills that I'm honing to get my grade 7, grade 8 at GCSE? If in 10 years' time you think, well, these skills aren't actually skills that are relevant to the kind of stuff that's expected of me, I wonder if. So here's where I think it might change. I think exams may stop being a question answered, by an examiner and everyone gets the same question. I could imagine exams being AI type things which are more like an interview, which ask you a question, and if you can't do it, they give you a hint and they take you through and take you as far. So they really understand how you think.
Yeah.
Because that's, how you would test people if you didn't have hundreds of thousands of papers to mark and all this kind of thing. But so we've already got something close to that. So we might be able to more purely learn real mathematical skills rather than exam passing skills. I think exam passing skills might become less important.
Yeah, that would be a lovely thought, wouldn't it? And I think what you were saying about certain mathematical skills, to me, I think it's we've perhaps moved too much towards valuing mathematical facts or knowledge, and actually what we really want is the skills so that you can, figure out what to do when you don't know what to do. And those are the things that we value because, as you say, we already live in a world where if you don't know a fact, you can look it up very quickly. But if you can't then use that in context, it doesn't really help you at all. So I wonder whether we move to a place where, we value the knowledge of, Pythagoras' theorem, for example, but in terms of the skill of how to apply that when you're given it, that might be more useful. I don't know. Um, just thinking aloud. Anyway, thank you so much for your time this afternoon, Rob. Really do appreciate it. If people want to find out more about what you do, find out about your books and maths inspiration and the school workshops and things, where's the best place to find out?
I've got a fairly rare surname, so as long as you spell it right, Eastaway, then it tends to crop up. So I've got a website, robeastaway.com. Yeah, if you're a school in Southeast London, get in touch because, as I say, I do my talks for free pretty much. With certainly in Southwark, any school. So there will be a few of your three. So it's hard enough for schools to set aside any time for anyone to come in. Period. Let alone have to find some budget to pay for it. So, um, but I love going into schools and sharing this stuff and reminding everyone that maths can be fun. So I suppose that's the word that I'd love in the best possible sense, not silly, distracting fun, but just stimulating, interesting.
Yeah, yeah. curiosity. Yeah. Thank you so much, Rob. As I say, I really appreciate your time, and I know the listeners will have taken lots from it. And if you do happen to be in Southeast London, I would highly recommend you do drop Rob a message. Because yeah, it would be great to see those pupils inspired by maths, which is what we're all aiming to do. I'll be back on Friday, hopefully with Becky, for another Aftermaths episode where we'll take apart some of what Rob said today and think about it a little bit more. But in the meantime, if you've got any questions or anything that you would like us to cover on the podcast, the best email to get in touch with us is primarymathspodcast@twinkle.co.uk, or find us on any of the social media apps. Once again, Rob, thank you so much for your time, and we'll see everybody else on Friday.